Last year we studied radioactivity, and we established that Marie Curie discovered radioactivity, and it was not a chemical reaction. So radioactivity is not a chemical reaction, it is a nuclear reaction. And what happens is that the nucleus of the atom actually releases parts of itself. We call it decay. And the particles you need to be aware of, it's not hugely in the curriculum, but you do need to be aware that an alpha particle consists of 2 protons and 2 neutrons. That means that it really is a helium nucleus. It's a helium that's got no electrons. Then you've got a beta particle, and that is electrons that are shot out, and gamma rays are energy from the nucleus that are shot out. And those all constitute types of radioactivity. We're not going to study radioactivity in detail. What we're now going to start looking at is how is the atom made up to chemically react. So, don't forget this guy. It's called the periodic table. You will remember from last year that these were the groups of the periodic table. So it's group 1, group 2, group 3, 4, 5, 6, 7, and 8. You will recall that you've got a line over here that divides the metals and the non-metals from one another. We'll go through this in quite a lot more detail later. These are the transition elements. But what's important to notice at this point is that the elements go up. Hydrogen is 1, helium 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a beautiful little counting game. And what is increasing as we go along in the periodic table is the number of protons. So the stuff in the middle of the atom. Now let's think about what an atom consists of. So in the middle of an atom, and we've talked about this quite a few times, there's going to be some positive charges and some neutral particles. And this is what came out of the Copenhagen atom. Floating around it in a very, very wide orbit are some electrons. In the space around the nucleus, you're going to get these electrons, and then their energy levels. So what is on the periodic table here is the number of protons in the nucleus. Generally speaking, as we increase the number of protons, the electrons increase in the same order, because that would keep everything neutral. And because neutrons have no charge themselves, they don't upset the neutrality if there are too many or too few of them. So in the middle you get these things called nucleons, and nucleons is just a name for all the particles in the nucleus, so we know that those are protons and neutrons. Each nucleon has a mass of what we make very simple, 1. What is that mass? An atomic mass unit. What is 1 atomic mass unit really? It is really 0.0000000000167 of a kilogram. So in other words, 590 million nucleons have a mass of 1 gram. In other words, an atomic mass unit is just really, really small. The good news, you don't need to know this. You just need to know that protons and neutrons have the same mass, and they are 1 atomic mass unit. Protons are positively charged. They've got a charge of 1, and neutrons are neutral. The number of protons is given by something called the atomic number, which I just spoke to you about, was 2, 3, 4, 5, 6, 7, 8, etc. That's the atomic number. If you take a look at the periodic table on your information sheet, you'll notice that there's an atomic number that goes up all nicely like that, and there's also another number, and that number is called the mass number. And let's think about the mass. Where does the mass come from? It comes from the protons and the neutrons together. So if I'm interested in the number of neutrons, I can just take the mass number, which is about 7 here, take away 3 protons, and therefore there will be 4 neutrons. If I take 16 minus 8, there are 8 neutrons. 14 minus 7, 7 neutrons. 12 minus 6, 6 neutrons. 4 minus 2, 2 neutrons. You will notice that in these smaller elements, the protons plus neutrons, they're a very similar number really, most of the time. And if you add them together, you get the number of nucleons, which is the mass number. Now, the thing with the mass number is that you are noticing that it is not a pretty little whole number at all. In fact, it's inconveniently quite ugly. So what makes it a decimal? Either you've got 1 neutron or 2 neutrons or 3 neutrons, right? In a specific element, you are right. However, there are things called isotopes. And we'll talk about isotopes in a bit more detail in a short while. But basically, an isotope has got the same number of protons and a different number of neutrons. And what this number represents here is an average of all the isotopes of a certain element. And so, for example, when we take a look at something like hydrogen, we have got hydrogen with no neutrons. So hydrogen 1, 1, hydrogen 1, 2 with 1 neutron, hydrogen 1, 3 with 3 neutrons. That is called tritium. Interestingly enough, hydrogen actually has names for theirs. This is hydrogen, this is called deuterium, and this is called tritium. It's the only element that's got names for the isotopes. The others, you would just call it carbon 12, carbon 13, and carbon 14. And then if you average them in their ratios of how much they are, you'll end up getting that number over there, which is a decimal because it's an average of different isotopes that occur naturally on Earth. We can't forget about this guy called the electron. They are negatively charged. They have got virtually no mass at all. It's 1/1840th of this tiny, 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 tiny number. So it's absolutely insignificant. But they take up all the space or the volume of an atom. Elements have got charge. The proton is positively charged and the electron negatively charged. You'll notice they are charged by the exact same amount. So we sometimes just say the charge of plus 1 electron or minus 1 electron. Your information sheet has this number on, the charge of an electron, 1,6 times 10 to the negative 19 coulombs. You do not need to memorize that at all. The charge of an electron cancels out the charge of a proton and vice versa, so together they are electrically neutral. Atoms usually occur in an electrically neutral state, so they have an equal number of protons and electrons. If a neutral atom loses an electron, it's then positive and we call it a cation. If it gains an electron, it becomes negatively charged and we give that the name an anion. You do definitely need to know what an anion and a cation are. Atoms do not lose and gain protons under normal circumstances, since protons are tightly bound in the nucleus. That would be a radioactive nuclear reaction. So the only thing that participates in bonding is electrons. Now what if I give you something like this? I say something like chlorine 1737 negative. How many protons are in there? Well, the smaller of the two numbers given here must be the atomic number, and that is the number of protons. So atomic number is always the smaller of the two, and it gives me the protons. And in this case, it's 17, so it's the smaller. The next number that's interesting to me is 37. It is the mass number, and the mass number tells me the protons plus the neutrons, which is equal to 37. It's the bigger of the two numbers. So therefore, the number of neutrons is equal to protons plus neutrons minus protons alone. And in this case, it is going to be equal to 20. Finally, I have got a minus sign up there. Normally, chlorine will have 17 electrons. But the fact that there's a minus charge over here, and therefore it is an anion, tells me that there's plus 1 extra electron. I've just put it there. So there are 18 electrons. Let me do one more example. Let's say I had something like hydrogen plus 1, 3. So the atomic number is the smaller of the two. It doesn't matter if it's at the top or the bottom. So the protons is equal to 1. The neutrons is always equal to the mass number minus the atomic number. 3 minus 1 equals 2. And finally, it's got a plus 1 charge. Normally, it would have the same number of electrons as protons. But in this case, they say plus. that means it's positively charged. It has lost an electron, -1, and there are no electrons on that particular hydrogen. Isotopes we will go into in a little bit more detail going forward. They are atoms with the same number of protons of the same element. So all oxygen atoms have got 8 protons, but some of them have got 7 neutrons, some have got 8 neutrons, and others have got 9 neutrons. Atoms of the same element, this definition you need to know, that have different numbers of neutrons are called isotopes of that element. We will do an example in the next video.